Okay, so what we're learning today is about 4 segments. This chapter is all about segments that are inside triangles. And today we're going to learn about 4 of them. One of them is called a perpendicular bisector, one of them is called an angle bisector, one of them is called a median, and one of them is called an altitude. So we're going to spend the majority of the class just talking about what these are. And then I have a notes paper that has 3 examples on it. So, perpendicular bisector. You need to know 2 things about it. Write this down. Write down that it's in a triangle. See, a perpendicular bisector can be outside of a triangle. It can be, you can have a perpendicular bisector and not have a triangle. But we're doing perpendicular bisector in a triangle. And so there's 2 things you need to know about that. You need to know that a perpendicular bisector bisects a side of the triangle. Bisects a side, a segment of the triangle. Bisect means it cuts it in half. So if you want to add that, it cuts it in half. So it bisects a side of a triangle. That means it cuts it in half. And it's not only a bisector, it's a perpendicular bisector. So that means it's also perpendicular to that side. So also perpendicular to that side. So I'm going to draw a triangle. And when you draw a triangle on this chart, all the triangles that I'm going to draw, I'm making them purposely scalene. If you draw them a little too perfect, like an equilateral triangle, you're going to trick yourself into thinking things are true that are only true in that special case. So that's why I don't draw an equilateral triangle, like a perfect straight up kindergarten triangle, because you'll think things are true that aren't true. All right, we're going to take one of these sides. Doesn't matter which one. It's easiest to work with the bottom one. So I'm going to take this bottom side and I'm going to perpendicular bisect that side. I'm going to bisect it with a perpendicular, okay? So bisect means we're going to cut it in half. So we need to find the middle of this side right here. And just like yesterday's lesson, if I was being super particular, I would grab a ruler and I would measure that and I would half it and I'd find the exact middle with a ruler if I was being super particular. But to save time, we're just going to eyeball it. So I'm going to find the middle of this side. It would be about right there. Now, since I don't know for sure that that's the exact middle, I don't know that for sure. I think it's, pretty darn close, but I don't know for sure. You put little hash marks so that the viewer, whoever's looking at this, knows that that's the middle. So you find the middle. And then at that point, because now it's bisected, that side is bisected, at that point, you're going to draw a perpendicular. So from there, you're going to go straight up so that that's a right angle right there. Now, if you want to be super particular, grab either an index card or a Post-it or a corner of a piece of paper, because they have right angles in the bottom corner, right? And you can put it in there and make sure that you've got a right angle. So that is called a perpendicular bisector. That segment right there is bisecting this side and it's perpendicular to that side. So I'm going to mark this right angle right here. This one over here is also a right angle. They usually just mark one of them, but they're both right angles. So that's also a right angle. Usually they just mark one of them. That's how you can recognize a perpendicular bisector. It's bisecting a side, and this is perpendicular. So that's the first one. Now, there are 3 perpendicular bisectors in a triangle. If I draw all 3 of them, the picture gets really crazy, so I'm not going to do that. But you could draw a perpendicular bisector right here. So you would find the middle point and you would draw a right angle. And then you would find the middle point of this side and draw a right angle. And you could draw all 3 of them, and they're going to cross at a point, but the picture gets a little crazy if you do that, if you draw all 3 of them. So I don't want to mess up the picture. I did do that for you on the other side. So if you turn this over, down here, I drew all 3 of them. Now, I drew them where I kept going. I made the whole line instead of stopping at that point. But that's what it would look like if you drew all 3 of them. So the picture gets a little crazy looking. And that's why I want you to draw just one of them. All right, the next one is called an angle bisector. So add these words, in a triangle. An angle bisector in a triangle. So you start at a vertex. I guess I should put starts at a vertex. So starts at a vertex, and it bisects the angle. That's why it's called an angle bisector. This one is the easiest one to me because the name of it tells you what it does. An angle bisector bisects an angle or cuts an angle in half. So bisects an angle of a triangle. And remember, bisect means cuts it in half. Okay, the main difference I need to point out between a perpendicular bisector and an angle bisector is a perpendicular bisector bisects a side, and an angle bisector bisects an angle. So you got to be careful about that difference. An angle bisector does just what its name says it does. It bisects an angle. So I'm going to draw a triangle. I'm going to draw that same kind of triangle. You could draw any triangle you want. I just don't want to draw a special case, because then it'll trick you into thinking things are true that aren't true. I'm going to pick an angle. It doesn't matter which angle you pick. I think I'll bisect this one. And then I'm going to draw a segment right through the middle of that angle. Now, when you draw an angle bisector, don't just slap a segment in there. Like, carefully make sure it goes right through the middle of the angle and splits the angle in half. Only the angle is split in half. So I'm going to draw a segment right through the middle so that the angle on either side matches as best I can. Now, if I was being really particular, I would grab a protractor and I would measure that angle, and then I would cut it in half. So if the angle measured, let's say it measured 60 degrees, then I would measure a 30-degree angle here and a 30-degree angle here and make sure it goes through the middle. But I'm just eyeballing it to save time. Now, I don't know for sure that I went right through the middle, so I mark it like this so that the viewer knows that those angles are the same, which makes that a bisector. That is how you mark an angle bisector. Now, you could bisect this angle, and it would be coming down like this, and you could bisect this angle, and it would be going up like that. So there are 3 of them. Just if you draw all 3 of them, the picture gets a little crazy and crowded, and you kind of lose sight of what it is. So I just drew one of them, but you could draw all 3. All right, so on the back, I drew all 3 of them for you. In this picture right here, that's a picture of all 3 angle bisectors. So if you draw all 3 of them, they're going to cross in the middle, like that. See, the picture just gets crazy looking. There's too much. So we got perpendicular bisector, we got angle bisector, and then there's 2 more. There's median and altitude. So the next one is called a median, and a median also starts at a vertex. Starts at a vertex. And it goes to the midpoint of the opposite side. So it goes to the midpoint of the opposite side. Starts at a vertex, and it goes to the middle point of the opposite side. That's why it's called a median. You guys learned about, when y'all were in probably late elementary school, maybe early middle school, you learned about mean, median, and mode. Do y'all remember doing that, mean, median, and mode? The median was when you had a list of numbers in order, and you found the middle number. That's called a median. And you've also heard the word median when you're learning to drive, right? That barrier in the middle of the lanes is called a median. And I don't know if you guys have ever noticed before, but that median separates an equal number of lanes on either side. So like when you have a median in the middle of the road, there might be 2 lanes on one side and 2 lanes on the other side, or 3 lanes on one side and 3 lanes on the other. That's what the median does. It splits the road into equal lanes. So median just means middle. So when you see that word, think middle. And the reason I didn't put in a triangle is because a triangle is the only thing in geometry that has a median. So if you're talking about a median in geometry, you're talking about a triangle. So you don't have to distinguish it from other things that have medians. Only a triangle has a median. So draw the same triangle. And this time I'm going to draw a median. So I'm going to start at a vertex. It doesn't matter which one. I think I'll start at the top one. And I'm going to connect that vertex to the middle of the opposite side. So I need to do what I did for perpendicular bisector. I need to find the middle of this side. And since I'm not being very particular, I'm just going to eyeball it. You could get a ruler, measure it, go over halfway. So the middle would be about right there. I'm going to mark this. That way the viewer would know that that's the middle. That's how you mark a midpoint, a middle point. And then you just connect the vertex to the midpoint of the opposite side. So this vertex to the midpoint of the opposite side, that thing's called a median. Okay, one thing to be careful about. An angle bisector only cuts the angle in half. It does not cut that side in half. A median only cuts this side in half. It does not cut the angle in half. So it only does one thing. So a median only cuts this side right here in half. It does not cut this angle in half. And the angle bisector only cuts the angle in half. It does not cut this side in half. So make sure you know that that term only means one thing, okay? And then the last one is altitude. And altitude also starts at a vertex. And instead of going to the middle of the opposite side, it makes a right angle with the opposite side. So it starts at a vertex and it's perpendicular to the opposite side. So it doesn't go to the middle. It makes a right angle with the opposite side. So I'm going to draw that triangle. And I'm going to start at a vertex. I'm starting at the top one. And instead of going to the middle, if I drew this to the middle, I'd be drawing a median. But I'm not doing that. I'm drawing an altitude. So an altitude, what it does is it drops straight down. It's kind of like if you dropped a string with a weight on it. It would just drop it straight down like this. And what would happen is it would make a right angle right there. So if you had an index card handy or a Post-it handy or the corner of another piece of paper, you can use that as a right angle to see that that segment is dropping straight down and making a right angle right here. And on the other side too. They usually just draw one of them, but whenever you have one, you have another one right behind it, like that. That's an altitude. So those are the 4 terms. There's perpendicular bisector, there's angle bisector, there's median, and there's altitude. Now here's the hard part. The hard part is that you're going to need to be able to tell which one it is just based on what's marked. So the hard part about this lesson is you have to pair these markings with that word. So whenever you see perpendicular bisector, these are the marks you can put. And whenever you see angle bisector, these are the marks that you can put because it's angles. And whenever you see median, these are the marks that you can put. And whenever you see altitude, you mark these right angles. So the hard part is knowing what these words give you in the drawing. And if you can do that, then these are really easy questions. Okay, so we're going to do some examples. Keep this out because you might want to refer to it. Let's see. There's 3 examples of this. Okay, sorry music people, I was passing out notes papers. All right, today is the 3rd, right? 12-3. This is 4th period. Okay, so here's what's going to happen. They are going to give you a word. Bisector, angle bisector, or median, or altitude, or perpendicular bisector. They're going to give you one of these terms, and you have to know what to mark in the drawing, and then the marks in the drawing give you the equation. Okay, so I'm going to say that again. The word gives you the markings, and the markings gives you the equation. So I'll show you how that works. It says segment RG is an altitude. Here's the word altitude. So you need to know what you should mark if you were given an altitude. And an altitude starts at a vertex and drops straight down and gives you a right angle. That's what an altitude. So when you see the word altitude, this is what it gives you. It gives you a right angle. And you can tell that from this picture right here. So this is what it gives you. It's like there's a weight on a string that drops it straight down and makes a right angle right here. So the only thing we can mark when we see the word altitude, the only thing you can put in here is that right angle, because it's like this is a weight on a string and it drops it straight down and makes this right angle. It also makes a right angle over here, but we don't need that. Okay, so somebody give me an equation.
3 times x equals 90, x is 30.
Yep, 3x equals 90. So you don't do anything with these guys. And now you may be wondering, why on earth are they there? Well, if they weren't there, it would be kind of obvious, even if you didn't know anything, what to do with this question, right? So they're there to see if you really know what an altitude is. And if you really know what an altitude is, you know that all it gives you is this right angle. So that's your equation, and then you solve it. So divide by 3. X is 30. So altitude gives you a right angle. So that's what I meant by the word gives you the mark, and the marking gives you the equation, because you're marking a right angle, 90, and it's 3x. So the word gives you the markings, and the markings turn into an equation. All right, example 2. This time it says segment MT is a median. So the word is median. And remember when we wrote on your tip chart a minute ago, think middle. When you hear the word median, think middle. It's that thing in the middle of the road. So what a median does, it starts at a vertex, starts at M, because it says it's segment MT. It goes to the middle of the opposite side. Now, my picture's a little out of scale, and sometimes they'll make these pictures out of scale on purpose to see if you know from the word what should be happening. So it goes to the middle of the opposite side. So this is the midpoint. That's what a median does. It starts at a vertex and it goes to the middle, which means that these two halves are equal. This one over here is equal to this one. Those are the marks you can put. And if you want to use this to help, that's when you see the word median, see, that's what this one is. These are the marks you can put. So when I see the word median, these are the marks I put. And then that gives you an equation. See, the marks give you an equation. So what do these two marks mean? that they're equal. So you go 2x minus 3 equals 3x minus 12, and then you solve that thing. So it has nothing to do with the 5x and the 3x. And if you're wondering why are they there, well, that's just to see if you know the difference between a median and an angle bisector. And this one has nothing to do with the angles. So then you solve that. So if you haven't already, solve that real quick. You guys do the algebra part. Brandon, how you doing? You doing this algebra?
Yes, ma'am.
Okay.
Miss Strickland,
Yes?
we need Carly Sabat to check out, please.
Okay, thank you.
Thanks.
I need to get the homework from yesterday and tomorrow too.
Okay, so the homework is from the book, and that's actually tonight's homework.
Okay.
I did the lesson yesterday, but it's tonight's homework. And then what else did you need? This is just blank notes from yesterday.
Okay, I'm gonna be gone tomorrow too.
Okay. Yeah, I have worksheets, but they're posted on Google Classroom. You can just print them from there.
Okay. Thank you.
All right, so hopefully you guys got x over here and you got 9 over here. If you did not get x equals 9, we might need to talk about some algebra sometime soon. But you just subtract 2x from both sides, add 12 to both sides, you get 9. Okay, last one. It says ray AB is a perpendicular bisector. And if you look at this, it'll help. If you want to see what marks to put when it's a perpendicular bisector. You mark these right angles and these hash marks. So both of those things can be marked when it says perpendicular bisector. So it's perpendicular, which gives you right angles. And it's bisector, which gives you hash marks like this. So that's what a perpendicular bisector does. And so what I'll mark is this right angle and these hash marks. So it'll give you two different equations. It'll give you the equation with the right angle, and it'll give you the equation with these segments. So the angle one would look like this. 4y equals 90. And the segment one, because it's a bisector, it bisects a side, it would look like this. 5x minus 2 equals 3x plus 10. So when it's a perpendicular bisector, you have two different parts, the perpendicular part and the bisector part. And then you solve these. Bless you. So to solve this one, divide by 4. And that comes out ugly, because 90 divided by 4 is 22.5, 22.5. And then this one, subtract 3x from both sides, you get 2x. Add 2 to both sides, you get 12. Divide both sides by 2, you get 6. So perpendicular bisector gives you two different equations. All right, so that's what this work is going to look like. This is not tonight's homework. Okay, this is tomorrow's classwork. Will look like these. Tonight's homework is going to be the mid-segment stuff from yesterday. Okay, so here, I'm going to turn this off.